So this video is going to go through a few examples of how to write a linear inequality, or perhaps a system of linear inequalities if you're given a graph. So this is going to be an example of kind of the most basic type of problem that we have. We are given a graph and we are tasked to write an inequality that would represent the graph that's given. So over on the left-hand side here, what I have is a list of steps that can help us do these types of problems. So the first thing that we're going to do is we are going to determine the borderline. Now we know that this is going to be an inequality, but for right now we're just going to ignore the inequality, and we'll come back to that in step 2. Now the one thing that they want us to kind of pay attention to is the number of borderlines will match the number of inequalities. So for example, on this problem right here, there is one borderline. So we should have one inequality. So for the borderline, I'm going to use slope-intercept form, so I can see the y-intercept is the point 0,1, and I can see the slope is up to and over 1. So the borderline, I'm going to ignore the inequality symbol, so I'm just using a box to represent where the inequality symbol would go. I know the slope is a positive 2x, and the y-intercept is a positive 1. So again, all I'm indicating here is a blank for the correct inequality symbol. And we're going to figure that out in our next step. But first, we just want to get the borderline. Now, what it says for our next step is we are going to pick a solution. Now, it also reminds us that the solutions are the things that have been shaded in. So for us, all of these things here have been shaded in, so these are all solutions. So if we just pick one, so I'm going to just randomly pick this point right here, and I'm going to label the coordinates of that point as -2, +2, and again, you could choose any point you want that's over here. Doesn't matter. Now what they're telling us to do, or what the directions say, is that if the solution is shaded in, then it's going to make the original inequality true. So what I can do then is I can take the original inequality that I've started, right? I have everything but the inequality symbol. And instead of my x's and my y's, I can plug in my test point. So if I plug in the y value and the x value, I would get 2, some sort of inequality symbol, 2 times -2 plus 1. So when I simplify this, we get -4 plus 1. So the idea here is I'm comparing the number 2, and -4 plus 1 is just -3. So we need to put a symbol here. This must be true. Because if we go back originally, this point, 0,2, was a solution. And I know that if I plug a solution in, it should make the original inequality true. So if we need to make the original inequality true, like if we need to make this inequality true, right, when I plug in the point, 2 needs to be greater than 3. So I know the inequality symbol would have to be eating the 2. So up here, I'd make it be facing to the left, just like it was down here, same direction. So then the last step is just verifying, because how am I supposed to know or not whether I'm supposed to put that equal to or not have the equal to? So the thing that we need to look at is use the picture of the borderline to consider if we should put the equal to. Now in this case, since it's an open or dashed line, we do not need the equal to. So our final answer is this. This is the original inequality that was used to make this graph. Now with another example like this, we can see that it is a system of inequalities. So we're still going to do the same process, but here the number of borderlines is going to match the number of inequalities. So the first thing that we're going to do, we have 2 lines. I'm just going to label them. So we're going to call this our first line, which I've highlighted in blue. And then we're going to call this our second line, which I've highlighted in red, so I can keep my work in order. So for the blue line, I again am going to use slope-intercept form because I can see the y-intercept is right here at 5. I can see the slope of this line is something like up 1 and over 2. So the slope of this line is 2x, or sorry, just 2, so the equation is 2x, and then the y-intercept is 5. The other inequality, the red one, again, I am also going to start with y-intercept form because I can see the y-intercept is right there at -2. So the slope of this line is down 1 and over 1, so -1 is the slope, and then the y-intercept is a -2. So what we're going to do now is, again, we need to pick a solution that's going to help us determine the symbols, but in this case we just got to do it for both of them. But if it's a system, we still have to choose from the solutions. There's only one solution region to the entire system, so I'm going to choose any number that is in that shaded region. So just for this case, let's go ahead and choose a nice easy number like -50. And by number I mean point. So if I plug in that point into this inequality first, we get 0 being compared to 2 times -5 plus 5, so 0. So -10 plus 5 is -5. Now the number that we chose, or sorry, the point, this was a solution, so this needs to be true. So to compare 0 and -5, 0 needs to be bigger. So I'm going to go put a greater than sign there, and then I go back and I consider the borderline to help me think if I need an equal to, and since this borderline is solid, I do need an equal to, so I'm going to go ahead and put the equal to component in my inequalities. So there's my first inequality. I'm going to repeat that process for the second inequality, and since, again, this is a system, I can go ahead and just plug the same point into this inequality. So 0 bigger than or equal to the opposite of my x point, and then -2. So if I simplify, now again, I chose a point that is a solution, so it needs to be true, so the only way to make this true is to say that 3 is bigger than 0. And then I go again to consider the picture for the borderline, and this borderline is open, so I do not need an equal to. So this was the original system that was used to create this graph. Here we can see the main difference that, again, we're still given the directions to write the system that was represented by this graph, and again, what we're looking at here is that the number of borderlines will match the number of inequalities, and here we can see that there's 3. There's this one I'm highlighting in green, there's this one I'm highlighting in blue, and then there's this solid one that we are highlighting in red. So for this case, we're just going to have to do 3 of them. So I'm going to use my colors to keep track of which one I'm working on. So for this case, we're going to do the first borderline. Now the first borderline is a vertical line. If it's a vertical line, we know it's in the form x is being compared to a number. So on this line, all x's are 4. So the borderline can be represented by the inequality x being compared to 4. The next borderline we're going to do in blue. The next borderline is a horizontal line. If it's a horizontal line, we know that the equation or the inequality is always in the format y is being compared to a number. And we know on this line, all the y values are 1. So this would be the inequality y being compared to 1. And then our last one looks a little more familiar. It's just kind of a standard line. So I can see the slope of that line is -1. And I can see the y-intercept of that line is +1. So I've written all 3 starts of the borderlines. So what I need to do next is I need to pick a solution. Now the solution region is shaded. It's a little bit smaller here because we're looking for where all 3 of them would be true. So in this case, I'm going to choose one point, and it's a solution for all of them. So the solution I'm going to choose is right in the middle there. I'm just going to choose the point 3, 0. So if I plug 3, 0 into my first inequality, the x value is 3, and it needs to be compared to the number 4. And since it was a solution, I need to make this true, and I know that 4 is bigger than 3. When I go back and look at the original borderline, which is green, it is dashed, so I do not need an equal to. So the first inequality was x is less than 4. Testing the next inequality, if I plug in the point 3, 0, the y value at that point was 0, and that's being compared to 1. And again, that was a solution, so it needs to be true, and 1 is bigger than 0. The next thing I noticed too, this is also an open line. I don't need the equal to component, so I just copy the inequality symbol. So there's my second inequality. When it comes to the last borderline, we're going to test the 3, 0. So I plug in the x and the y value, and I simplify. So -3 plus 1, that's just -2. And since this was a solution, it needs to be true, so 0 is bigger than -2. The last thing is I can see that this is a closed line, so I do need an equal to component. So these three inequalities are what made up the original system that produced this graph. So we're going to do one more example here. What we do notice is that we are still charged with the same directions. We need to write a system of linear equalities that is represented by this graph. But just when you look at it right away, and what makes this one special is it appears as if there's no shading, right? And if there's no shading, it's going to mean to us there's no solutions. So we'll have to account for that when we're trying to, over here in step 2, we're trying to pick a solution. So this will be the special case on, like, what am I supposed to do when this happens? So we still can start by determining the borderline. So just so we can keep our lines straight, I'm going to call this one the blue line, and we'll call this borderline the green line. So for both of those, we can see the slope and the y-intercept. So let's start with the blue one. So I can make that a little bigger. The slope of the blue one looks to be down 2 and over 1. So it's a slope of -2. And the y-intercept right here looks to be -3. When I do the green line, again, I can see the slope is also down 2 and over 1. These lines appear to be parallel. And then the y-intercept is -1. So just like before, I'm able to start my inequalities. I just have to figure out the inequality symbol. Now, when I'm trying to figure out the inequality symbol on this one, our original method required us to pick solutions, and we don't have any solutions. So we won't be able to do that. So what we have to think about is how would we get no solutions? So if there was no solutions, that would mean that there is no overlap in the shading. If there was no overlap in the shading, that means that there was no final solution region. So the only way that we could make that happen, if I think about the original picture, if I shaded below this blue line and on top of this green line, there is no overlap. And again, think about the other combinations. If I shaded on top of this blue line, no matter where I shade, either above the green line or below the green line, they overlap. So what I want to do is create a picture that has no overlap. So this is that picture. If it was shaded below the blue line and above the green line, there would be no overlap. So what I had to do is I imagined what were the solutions to the original inequality. So I sketched those in, and now I can pick a point. Like, so for the blue one, the point -4, 0 was a solution to the blue one. So when I plug it in, -4, 0, that should make the blue inequality true. So here what I would need to do is I would need to make 5 bigger than 0. And since there is an open line, I am going to use just a less than. Now when it comes to the green one, I want to choose a point that was a solution for the green one. So how about that point right there, which is 1, 1. If I plug that in, and I simplify, -2 minus 1 is -3. Again, for the green one, that point worked. So for the green one, I would want to make this true, which is a greater than. And again, it's an open line. So the original inequalities would be here. And I can go back and test that, right? Like if I tested the point 1, 1 on this side, which I'm going to do in green here, 1, 1 is not a solution. So if I plugged it in, 1 is not less than -2 minus 3. So we can see that this point, the green one, doesn't satisfy both of them, so I know that my picture is correct. So when it comes to a special case, what I was thinking here, just as like a summary, how do I figure out like where the inequality symbols go? We thought about how would we create a picture that had no overlap, and then we drew that overlap in, and then that kind of allowed us to go back to our original list of steps by picking a solution.